All right. Today we're going to finish out chapter 11. And the last section, section 4 in chapter 11, honestly is not very long. Okay. So it might not take us too long to get through this. Okay. Especially because there's, well, you know all the things that we need to know. We just have to put them together. So today is when we're going to talk about percent yield. Okay. So that practice that I gave you on Friday, and then I said, oh wait, don't do the one on percent yield. Today we're going to talk about that. So, basically, what this section comes down to is you can never be 100% efficient, I guess is the word, in your chemical reactions. Okay. Now, when we did limiting reactants and things like that,
I'm just following basic in that. Is that okay?
Okay.
Okay, and Wendy. Is she in this class? Yes. I thought she was in a different class. Thanks, I'll bring them right back.
So what we have is we said, okay, we're starting with this much, and we can get this much of whatever product we have. Okay. When you talk about real life situations, if you were to actually go into a lab, you never really get that much. Now you can have some reactions that get really, really close, but you're never going to get all the way there. So percent yield is just the idea of, well, how close did we get? Because if you were to have a 100% yield, then yes, you got all the way. You got every possible molecule to react. Once again, doesn't happen. So in order to talk about this, we need to introduce a couple of vocabulary terms. So we have theoretical yield. And that's what we were calculating, okay? The theoretical yield is what is the most you could get. Okay? The most that you could ever get out of this reaction given your starting reactants. Okay? Theoretical yield tells you what could you get. Okay? And then we have the actual yield, which is what you actually got. Actual yield cannot be higher, cannot be bigger than theoretical yield. Okay? If you have an actual yield that is higher than your theoretical yield, you've done something wrong. Now that thing that you've done wrong could actually be several different things. It could be that your actual yield includes some contamination. So you have different products in there. What you're measuring is not just the product that you were interested in. It could be that you miscalculated what you started with. Okay, maybe the balance said, 153 grams, but you read it as 123 grams. Okay, you flip the number around in your mind somehow and do the math back. Okay. That could be something that's going on. Or you could have simply done the math incorrectly when you were looking at theoretical yield. Either way, whatever the cause, if your actual yield is higher than your theoretical yield, you've done something wrong. You need to find where it is. So yeah, pretty straightforward. And then of course, to find the percent yield, well, all we have to do is actual divided by theoretical. And then it is a percentage, so we multiply by 100. Actual divided by theoretical. Multiply by 100 to give us our percentage. So let's walk through an example of how we will do that, what one of these problems looks like. Clean this up just a little bit here. So if we look at example problem 6, on page 386, percent yield. So solid silver chromate, and it gives us our formula, Ag2CrO4. It forms when excess potassium chromate is added to a solution containing 0.500 grams of silver nitrate. Determine the theoretical yield of the silver chromate. Calculate the percent yield if the reaction yields 0.455 grams of the silver chromate. Okay. So there's a lot going on. We just need to start breaking it down. See, what do we know? What are we trying to find out? Okay. Now, this is a stoichiometry problem. So what is step number 1?
Balance.
We need a balanced equation. Very good. Okay. So we have potassium chromate added to a solution, so that's solid. We're adding it to a solution of silver nitrate. Okay. And we get solid silver chromate. Now it doesn't tell us our final product, okay? That we kind of have to figure it out, but this is where knowing types of equations, types of reactions comes in handy. This is going to be a double replacement, okay? So we've taken the silver, we put it with the chromate. Well, that means our potassium has to pair up with the nitrate. Okay? Potassium nitrate. Let me get that.
Oh, so is it the Ag2CrO? Is it given by the question? Is it in the question?
Yes, that is the very first one. So solid silver chromate forms.
Okay.
So when it says that something forms, you know that it's going to be a product.
So the last thing will be NO and a K.
Yes, so we know that we've used this and that. So we have the potassium and the nitrate.
So we just combine it.
We put those together here. Yep. Because it's a double replacement. Okay. So now we just need to balance that. It's actually not too bad, especially if you use the trick of these are ions, so we can balance the entire ion together So if we have potassium as an ion, and then we do the entire chromate ion, because everywhere it's together, it's the CrO4. So if we balance that as a unit, that works. Then we get the silver, and same thing, NO3. So we have 2, 1, 1, 1. Over there, our potassium has 1, chromate has 1, silver has 2, and nitrate has 1. Okay. So you can really start anywhere you want. You can start here with 2 there. Then our silver on this side changes to 2, as well as our nitrate. Okay. And then, well, we need more potassium, and we need more nitrate, so I'm going to put a 2 right there. And that fixes everything for us. So now we have our balanced equation. So now, the next step, we want to calculate the theoretical yield. That's the only thing that we actually can calculate. The actual yield, we have to determine that in the lab. Okay. It's not something that we can say, oh, okay, here's an equation, calculate the actual yield. Okay. We do that in the lab. So, well, the theoretical yield, that's exactly what we've been doing. It's exactly what we've been doing. So it tells us we have half a gram, 0.500 grams of our silver nitrate. Okay. So that's where we're going to start. So what's our first step?
So I'm using the AG, just get rid of the G as a mole.
Okay, we need to convert to moles. Very good. How do we do that?
So we find the
Yeah, we need the molar mass. So we have to go to our periodic table. And 1 silver, 1 nitrogen, 3 oxygen. The book tells us that is 169.9. Okay. So now we've got it into moles. What's our next step? Divide by 2. Why are we dividing by 2?
To get the mole, like 1 mole of it, because you have to.
Because we have 2 there, is that why? Okay, yeah, we're going to use our mole ratio. So we put 2 moles of our silver nitrate. Okay. So now that's gone, that's gone, that's gone. What do we put up here? 1 mole? 1 mole of what?
silver.
So our silver chromate. Okay. Okay. So far, we've taken our 0.5 gram of our silver nitrate, converted it into moles, and then said, well, for every 2 moles of that we have of the silver nitrate, we're going to produce 1 mole of our silver chromate. And then the last step, we just need to convert to grams. Moles to grams. Once again,
1 mole, and then the gram of the mass of the what is it called? Silver chromate.
So we go to our periodic table. 2 silvers, 1 chromium, 4 oxygen. I'm just going to look at what they have in the book and trust that. 331.7. Okay. So now the only units that haven't canceled out, grams of silver chromate. And at this point, we do our math. Okay. So we do 0.5 times 1 times 1 times 331.7. We divide that number by 169.9 times 2 times 1. And what it actually gives us, 0.488 grams. Of our silver chromate. Okay. That right there is our theoretical yield. If everything reacted, we should get 0.488 grams of silver chromate. But, as we said, the problem gives us an actual yield. The actual yield is 0.455 grams. So our actual So now we can just take this right here, okay, our percent yield, take the actual, divided by the theoretical, times 100, okay, and this gives us 93.2%. So 93.2% is our percent yield. Okay. Means we got 93.2% of what we could have gotten. Double checking everything, making sure it makes sense. We did not get a number over 100. If you get a number over 100, like I said, that means your actual was higher than your theoretical and you've done something wrong.
So is it need to be lower than 100%?
Yes. You cannot have a number higher than 100% because that would mean that you've somehow magically created matter, which we know from the beginning classes is not something that we can do. So.
That's it?
And honestly, that's this section.
Oh, wow.
Yeah. Like I said, it's a pretty short section. So, yeah. Does that make sense?
Yeah.
Any specific questions? Okay. So, obviously there is some homework. I'll give that to you. There's that.